It's a little too early for us to do some calculation, Ariana Grande. And that was 34 plus 35 on Sean's radio. You know, I was so always bad at math at school. Naku, lagi na lang akong bagsak. My diction, on the other hand, though, was pretty good. Buti na nakabawi sa English.
We live in a universe of patterns. Every night, the stars move in circles across the sky. The seasons cycle at yearly intervals. No two snowflakes are ever exactly the same, but they all have six-fold symmetry. Tigers and zebras are covered in patterns of stripes. Leopards and hyenas are covered in
patterns of stripes. Leopards and hyenas are covered in patterns of spots. Intricate trains of waves march across the oceans. Very similar trains of sand dunes march across the desert. Colored arcs of light adorn the sky in the form of rainbows, and a bright circular halo sometimes surrounds the
moon on winter nights. Spherical drops of water fall from clouds.
The patterns in nature demonstrate the order and beauty of the universe. Mathematics is often used to explain these patterns, such as the geometry of Earth's orbit or the physics of light. The study of nature patterns has inspired mathematicians and scientists to develop mathematical models. The connection between math and nature highlights their deep relationship. Patterns is everywhere. Be observant in your surroundings.
Human mind and culture have developed a formal system of thought for recognizing, classifying, and exploiting patterns. We call it mathematics. By using mathematics to organize and systematize our ideas about patterns, we have discovered a great secret. Nature's patterns are not just there to be admired. They are vital clues to the rules that govern natural processes.
Development of mathematics as a formal system of thought for recognizing, classifying, and exploiting patterns is a testament to the human mind's ability to understand and make sense of the world around us. Mathematics has become an essential tool for scientists, engineers, and researchers, allowing them to model and predict natural phenomena with every increasing accuracy. By organizing and systemizing our ideas about patterns, we have been able to uncover the underlying rules and principles that govern natural processes. This led to significant advancement in fields such as physics, biology, and engineering, as well as practical applications that benefit humanity. Moreover, the discovery that nature patterns are not simply there to be admired but are instead vital clues to rules that govern natural processes is profound realization. It is a reminder that the natural world is not just a statistic collection of objects and phenomena, but instead a dynamic interconnected system that can be understood and harnessed for the better of society.
100 years ago, the German astronomer Johannes Kepler wrote a small book, The Six-Cornered Snowflake, as a New Year's gift to his sponsor. In it, he argued that snowflakes must be made by packing tiny identical units together. This was long before the theory that matter is made of atoms had become generally accepted. Kepler performed no experiments. He just thought very hard about various bits and pieces of common knowledge. His main evidence was the six-fold symmetry of snowflakes, which is the natural consequence of regular packing. If you place a large number of identical coins on a table and try to pack them as closely as possible, then you get a honeycomb arrangement in which every coin except those at the edges is surrounded by six others, arranged in a perfect hexagon.
My name is Maripolin Antoinette El Talento, and my reflection on the third quoted text is about the greatness of Johannes Kepler. About his theory, although he performed it without experiment, Johannes Kepler discovered that you can have an honeycomb pattern by just arranging the coins and turned it in the perfect hexagon. Because this quote cited that Johannes Kepler is a great mathematician because of his intelligence. And did you know that Johannes Kepler discovered two nebular polyhedra, worked on the problem of closing packing of equal spheres, compute logarithm, and found volumes of solid of revolution? And let's go back to the third quoted text. Although Johannes Kepler intentioned to write that book as a gift to his sponsor for New Year's Eve, it becomes a new theory for the mathematics that time, which is truly incredible. So be observant to your surroundings and you will see the clues of mathematics even we're not expecting it, like Kepler Johannes discovered to a mere snowflakes.
The regular nightly motion of the stars is also a clue, this time to the fact that the Earth rotates. Waves and dunes are clues to the rules that govern the flow of water, sand, and air. The tiger stripes and the hyena spots attest to mathematical regularities in biological growth and form. Rainbows tell us about the scattering of light, and indirectly confirm that raindrops are spheres. Lunar halos are clues to the shape of ice crystals.
My reflection for this is that it means that our world, the one we live in, is actually spinning. Thanks to science, we can see it, feel it, and experience it. Through the movement, what we experience can actually be used mathematically to know how, when, where, and why we rotate. For mathematical calculations of what we live in addition, everything that happens in our environment has a mathematical component that has been used to form or answer questions about its computation. Third, the formation of a lunar eclipse in which our world rotates and changes direction. The color and shape change each time the moon appears. A lunar eclipse can change by changing the color it normally appears in, such as red. This usually bothers most of us. Initially, scientists believe in the rotation of the world, like the waves and dunes that we often see around us, in our waters and oceans. The movement of water makes us think and ask questions. But is it really the wind that moves water and must adapt to the environment accordingly?
There is much beauty in nature's clues, and we can all recognize it without any mathematical training. There is beauty, too, in the mathematical stories that start from the clues and deduce the underlying rules and regularities, but it is a different kind of beauty, applying to ideas rather than things. Mathematics is to nature as Sherlock Holmes is to evidence. When presented with a cigar butt, the great fictional detective could deduce the age, profession, and financial state of its owner.
Overall, the fifth quote text has been emphasized how nature and mathematics are related and how each of them provides its own unique brand of beauty. Even if mathematics able us to find underlying structures and patterns in nature, there is still a certain quality to its beauty that mathematics cannot fully express.
The regular nightly motion of the stars is also a clue, this time to the fact that the Earth rotates. Waves and dunes are clues to the rules that govern the flow of water, sand, and air. The tiger stripes and the hyena spots attest to mathematical regularities in biological growth and form. Rainbows tell us about the scattering of light, and indirectly confirm that raindrops are spheres. Lunar halos are clues to the shape of ice crystals. There is much beauty in nature's clues, and we can all recognize it without any mathematical training. There is beauty too in the mathematical stories that start from the clues and deduce the underlying rules and regularities. But it is a different kind of beauty, applying to ideas rather than things. Mathematics is to nature as Sherlock Holmes is to evidence. When presented with a cigar butt, the great fictional detective could deduce the age, profession, and financial state of its owner.
This podcast is about the mathematical nature of numbers. What is mathematics in the nature of numbers? Mathematics in nature is a science and mathematics unit that allows students to explore and gain knowledge about mathematical patterns found in nature, such as tessellations and the Fibonacci sequence. Nature's Numbers is a great attempt by Ian Stewart to introduce mathematics as an important subject to human life and also introduce some important and fundamental concepts of mathematics. The main target audience of this book is people with elementary or limited exposure to mathematical concepts.
Mathematics is the fundamental subject that plays the crucial role in the everyday lives. It is an essential tool for problem solving, decision making, and critical thinking.